For this next example, we have the absolute value of w over 3 is greater than 2. Remember that greater is or. Less than and, but greater than is or. Let's go ahead and take this already isolated absolute value and break it into two pieces. We'll have w over 3 is greater than 2, or w over 3 is less than negative 2. Again, flipping the symbol of the inequality when you add the negative sign, because we're multiplying by a negative, the inequality switches. Let's solve this equation. In order to get rid of dividing by 3, I need to multiply both sides by 3. So 3 on top and bottom will cancel, leaving me with w is greater than 6. Here, I will also multiply by 3 on both sides. The 3's cancel, leaving me with w is less than negative 6. Remember that this is an or case, so when we go to plot this, we have 6, negative 6. We are going to have open dots at both of those. And it says w is greater than 6. So greater than 6 is going to head to the right. W less than negative 6 heads to the left. So x could be over here or x could be over here. It's on the opposite sides. So we cannot combine this into one single inequality. We have to actually write that w is less than negative 6 or w is greater than 6. It has to be two separate inequalities with an or. Example number 4, we are no longer have an isolated absolute value. We're going to have to do a couple of things to move all of the numbers to the right-hand side. Let's take a look. So we have 4 times the absolute value of 2x minus 5 plus 1 is greater than 21. We do note that we have an or case. We have a greater, and remember greater is or. Let's go ahead and simplify this and get all of those numbers to the right. So I'm going to subtract 1. Remember that whenever we are moving things, we always want to do adding and subtracting first, followed by any multiplying or dividing. So we'll be left with 4. Absolute value of 2x minus 5 is greater than 20. Now I want to divide by 4 on both sides to get rid of this 4, and I'll have absolute value of 2x minus 5 is greater than 5. We're finally in our isolated case where we can split into two pieces. So we have 2x minus 5 is greater than 5, or 2x minus 5 is less than negative 5. Let's solve each. The first thing again that we want to do is adding or subtracting, so I'm going to add 5 to both sides, leaving me with 2x is greater than 10. And then divide by 2. X is greater than 5. Over here on this side, we can also add 5 to both sides, leaving me with 2x is less than negative 5 plus 5 is 0. And when we divide 0 by anything except for 0, we get 0. So x is less than 0. Those are our two cases. Remember, this is an or. And we'll prove that to ourselves in a minute here. We have 0 and we have 5. We're going to have an open dot at 0 and open dot at 5. X is greater than 5. Greater goes bigger towards infinity. X is less than 0, headed over here. X is somewhere in between. So finally, we can write our statement. X is less than 0, or X is greater than 5. And that is our final answer to our inequality.